Right now, I'm in my grandparents' house, and I have a basic understanding of how it was made. But how was the solar system made? Well, for that we're going to have to go back about 4.5 billion years. Part 1. The Sun. Our solar system started out as a spinning cloud of gas from collapsed stars which exploded into solar nebulas. It eventually flattened out into a disk perpendicular to the spinning axis with a dense center. But why didn't the solar system flatten out another way, perhaps parallel to the axis of rotation? Well, the matter doesn't just have to follow the laws of gravity, it also has to follow the laws of conservation of angular momentum. This keeps the solar system spinning in the same direction it always is, unless acted upon by a greater force. That's why our solar system doesn't spin like this. In order for this to happen, as this graphic shows, gravity would have to be pushing in on the sides in one way more than another, which in an evenly dispersed cloud of gas does not make sense. This was the center of gravity, and the gas began to compact in the center, forming what would eventually become our sun. As the sphere of dense gas grew large in mass, it pulled in more gas and became a cycle. This used so much gas, what would eventually become the sun used up 99% of the available gas within what is now our solar system. It soon became so dense that the pressure in the core was high enough to form helium atoms out of hydrogen, also known as nuclear fusion. As the sun became more and more massive, its gravitational pull threatened to collapse the sun in on itself. The thing preventing this was nuclear fusion reactions going on in the core. This provided enough energy to counteract the gravitational pull, balancing the sun on a tightrope. The hydrogen within the sun's core provides this balance and is the sun's fuel, but it will not last forever, and in about 5 billion years the hydrogen will run out, forcing the sun to fuse heavier elements, both heating up the sun and causing the outer layers to expand. This process will last 1 billion years, with the sun expanding as far out to the Earth, which will incinerate it. Once this phase ends, the matter will collapse back towards the center and form a white dwarf, an incredibly dense, smaller star. This will last for billions of more years, but won't have the incredible size or mass of our sun. Part 2. The 1% of mass left. Seeing as the sun used up more than 99% of the solar system's available mass, what happened to the other 1%? Well, as the sun began to form, other regions of the nebula cloud began to clump together and increase in mass. Sounds familiar. However, these never had the success of the sun. These clumps of rock were numerous though, and began to collide to form larger and larger rocks whose gravities were intense enough to shape them into spheres. These became the 4 terrestrial planets, moons, and exoplanets, as well as large asteroids in the Kuiper Belt, Asteroid Belt, and Oort cloud. But what about the gas giants? Within the first tens of millions of years of the solar system's history, they start off as very dense terrestrial planets that are soon orbited by large amounts of gas. From here it gets a little bit cloudy on how the rest of the formation is done, so I'll leave some of my sources discussing different possibilities. Part 3. The layout of the solar system. Our solar system layout consists of the Sun, the 4 terrestrial planets, the asteroid belt, the 4 gas giants, the Kuiper Belt, and surrounding the whole solar system in a hollow sphere, the Oort cloud. So that's how the solar system formed. Stay tuned because a video is coming up about the frames of reference and speed of light. Anyways, have a great day. Subscribe if you want to see further content. I do science content and LEGO content. I'll see you soon. Bye.